Okay, so let's start today's class. So what we have been looking at is hierarchical clustering and K-means. So two models that we use for grouping our customers, so grouping our data based on similarities. So today we want to work on the practical aspect of it. And the first thing we will do is we will head over to Kaggle to get some sample data set. So once you open kaggle.com, we have the datasets part here. And what we are going to search for is maybe something like a supermarket dataset, okay? So let's click on classification and see some stuff that we can get here. Okay, so mobile price classification. So let's see this one here. So the mobile price classification dataset and see some of the columns we have here. So we have battery power, blue, if the device has Bluetooth or not, clock speed, dual SIM, front camera, is it 4G or not, internal memory, that and that. Yeah, so we can actually use this data for clustering and see which mobile devices have similar characteristics and how they've been grouped. So let me share this link with you in the chat and then we can proceed. So let me download the dataset. So this is the test data. So let me first check the train dataset and see what's in the train dataset. So we have 21 columns. Okay, so actually the most important column here should be the price range column, because what we are trying to see is what are the different price ranges we have here. So we have price range 0 to 3. So those should be the unique price ranges we have for this data set. So let me download this data. So train.csv, so it's a small file. Then I can upload it to my GitHub account if you want to access the data using a link on your notebook directly. So let me upload it here. Okay, so file has been uploaded. Then I can click on train.csv. Then I can click on view raw. Yeah, so that's mainly what we need. So let's create a new notebook. So I'll zoom in a little bit so that you can see what I'm doing. That should be enough. So this should be project1.ipynd. Then what we usually do is we start by importing libraries. So I'll copy that code from the K-means notebook. So we import pandas, we import numpy, we import matplotlib, seaborn, and then warnings. Then we can run them. So after that, I'm going to import the dataset. So we are going to have our data being equal to pd.read underscore CSV. Then I'll paste in my raw data GitHub link here. Then I can have data.head. So that works. Let me share this in the chat and I'll give you 2 minutes to work on setting up your Jupyter notebooks and uploading the file. So by 8:13, we will proceed on with what we are working on here. Okay, so you should be done by now. So the first thing we usually do is we check the kind of data we have. So what I'm going to do here is I'm going to type in df dot, not df, but data dot info. And then I'm going to see the kind of columns I have here. So this is our data after typing df.info. So you can see we have 21 columns, and all these columns are either an integer or a float. So we don't have any column that is not numeric. So yeah, that's what we have. So we have the battery power column, blue, clock speed, dual SIM. So these are phone features. And with these phone features, we can have the price range for the kind of phone we have. So what I'll do is I'll create a histogram for all the numeric columns. Okay, so what I'll do here is I'll create a, so what grid can work? Who can suggest a grid? So a 5 by 5. So I'll create a 5 by 5 grid of plots, of distribution plots. So here we will have our figure, then we will have our axis, then we will have plt dot subplots, then we will have our grid which has 5 items in it. So if I run this, you'll get to see the 5 different plots that we are going to have. So you can see these grids. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So we have 25 items in here, and we are going to plot them all. Or what I can do is I can reduce them to 4. Okay, so that we can have 20 items. Then we will plot all numeric variables except the price range column. Then here, this is what we are going to have. These are our plots. So I'm going to share the code with you because it's going to be a little bit big and you don't have to type all this on your side. Okay, so instead of doing this, we can just work with a for loop. Okay. So we can have columns being equal to data dot columns. So we get all the column names. Then for I in range 5, then for j in range 4, sns dot displot, then data dot columns, we get all of that. Then we can have plt dot show. So we might get an error because my column list has the price range column included, but I'm glad we have an output here. So you can see when working as a programmer, so the main thing you have to figure out is how do you solve your problems using less lines of code. So you can see from me wanting to type in whole the whole columns as they are, so using the first method that I had indicated here, so I switched to using a for loop because I knew a for loop would be short and it would easen my work, so I would avoid repetition. Let me share that in the chat section, and then maybe you can ask questions as we are reviewing these code part here. So if we check this, you can see, for example, so I've shared the code in the chat section. You can copy it and paste it in your code site. So here we are trying to do some EDA and see which columns here are discrete and which ones are continuous. So for example, if you check the battery power, you can see this column seems to be continuous because we have values ranging from 500 to 2000. Then the column blue is discrete because we have the values zeros and ones. So we have zeros and ones only. Then clock speed is again discrete because we have countable number of items. Dual SIM is discrete because it's either your phone will be a single SIM or a dual SIM. So these are some of the things you need to understand from the data. Then FC, I don't know the meaning of that, but this seems to be continuous. You can see by its distribution. So this should be a right skewed distribution. Then 4G, so is it a 4G kind of phone? Then internal memory, so the memory size. Then all these other variables. So those are some of the things you can check when dealing with these data. Okay, so I'll give you at least 3 more minutes to complete this code part and then we can proceed. In the meantime, you can ask questions or again, you can share suggestions on your side as to what you think we should do here, or maybe some EDA examples that you think we can work on. So 3 minutes you work on this part, then I'll create another plot for you. So remember, I've just downloaded this data for today. I don't know what the data contains, but I know the kind of task I want to fulfill using these data. So we want to group these fonts in terms of maybe cheap, expensive, or affordable fonts. Okay, so I think we can proceed. So what we want to now see again is how are these characteristics displayed when it comes to like the phone price, okay? Like the price range. Okay, so we have three distinct prices. So if I do something like sns dot count plot, then we select our data, then we select the price range column. Okay. So let me do this first. So data, then I select the price range column. Then we do something like a value count. You can see we have price range 1, price range 2, price range 3, and price range 0. So we have four different price ranges for these phones. So for the guys who came up with these four different price ranges, so what were some of the things that they used to like do this? So you need to know how they approached this problem, okay? And for us to do this, we need to first do some EDA on this data and understand how this was done. So what I'll do is I'll create the distribution plots again. So yeah, with the hue being this price range column. So there is an easy way of doing this. Instead of us using a list plot, what we can do is we can type in sns dot pair plot, then data, then the hue should be equal to the price range because that's what we need to like see. So we can have sns dot pair grade and plt dot scatter. Now let's work with the pair plot and see the different distributions we have for the different variables that we have in these data. So this will be the last thing we are going to work on EDA. Then we are going to feed a model to our data and compare these plot that we are going to get here with the labels that will be created using the k-means model or the hierarchical clustering model. So the disadvantage of using pair plots is it consumes a lot of computational power and you don't get the results as fast as you want. So I'll stop this, the pair plot code, and then I'll run my code down here. Let me restart my notebook because I'm still having an issue here with the pair plot part. So in the meantime, you can customize your code up here and just add the hue part. This plot has no hue. So let me research that first. I can see it's one of the arguments. So let me change this from dist to this plot and see if it's going to work. So we are getting an error. We can't do this for the different data set. Okay. So what I'm going to do is so instead of us having this, so I'm going to split the data into 4 groups. Then we can plot them again. Let's see if this works or if it's going to give us an error too. Yeah, so that works, but it's a little bit dirty. So you can't clearly see the plots that we have here, or you can't clearly visualize the different groups that you have here. But from the legend here, for example, if we check the Wi-Fi part, we can see the distribution of each Wi-Fi part here. So for example, for the pixels width, you can see there is a difference here. So, and for example, for RAM. So for RAM, you can see for price range 0, they have a lower RAM. For price range 1, they have a RAM that is in between here. For price range 2, they have something in between here. Then for price range 3, the RAM is a little bit bigger. So this is one of the column that shows some distinction between the 4 classes. Another one will be here. You can see, for example, for class 3 and 0. So class 1, the mobile phones tend to have a lower battery power as compared to class 3, which tend to have a higher battery power. So using these plot that I have here. Any other thing I can see is maybe the pixels height. So you can see the more the height increases, then the more the classes change. Okay. So those are some of the things we usually check. So since this is just an example, so we won't go deeper into the EDA part. So maybe I'll leave that to you to research more on it. And you can ask me questions and I'll be able to answer them. So this So the RAM part here is a perfect example showing you how you can observe the different price ranges for different phone RAMs. And from this analysis, maybe my conclusion will be that RAM is the most important feature in this dataset in determining the price of a phone. Okay, so let's proceed on to the next part without wasting time. So the next part will be to fit a K-means model. So what I'll do is I'll copy the code that we had used in yesterday's class. Then I'll change this part to just data. Then I'll drop the price range column. Before that, let me share this code. So apologies, I forgot to share that. So the only thing I've added in that code is this part here, where I group the data in terms of price range. Then we do the plots using the price range groups. So I'll give you 3 minutes. So maybe at 8:36 we can proceed. So 3 minutes, you copy that and then we can proceed. Okay, so I think we can proceed. So this is the next part. So where we import k-means, then we create our k-means data. Then from the k-means data, we instantiate the model. So here I will instantiate the model with 4 clusters because already we know the price range has 4 different price ranges. Then after that, we are going to do something like k-means.fit. Then we are going to have k-means data being fitted. Then we are going to extract the k-means label. So what I'm going to do is I'm going to say k-means data. Then I'm going to create a new columns called labels, and I'll let that be equal to k-means.labels. Then I can run my model. So my model is running. As my model is running, I'll copy this code up here and paste it down here again. So what I'll do is here, I'll create a new variable called price range groups, then name it k-means, should be equal to Okay, so there will be an error there. Should be equal to k-mean data, then group by labels. Okay, so let me check my k-means data first. So my model has fully run. I don't know if we have the labels column. Yeah, so we have the labels column. Then k-means data, then we will have the labels column there. Then here we will extract the k-means data dot columns. Then for price range groups, I'll change these to be k-means. Price range groups k-means, and then I can do the plot again. Then I can compare the plot that I have down here to the plot that I have up here and see. Maybe for example, we can use the RAM and see if the four groups correspond or match to what we had up there. So you can see, for example, if we check the RAM, you can see we have the different groups here for each RAM type. So we have this group here at the start, then the two groups in between that are overlapping, and the last group. So if we come back up here, you can see we observe similar characteristics, but for the k-means, they are not that much exact to what we had up here. And for example, for pixel width, you can see we have more distinct pixel widths as compared to what we had up here. So what k-means does is that it has grouped these products into four different products. And if we check the k-means labels part here, you will note that, for example, here you can say that if I was checking this data, so for already I mentioned that the RAM part will be the most important part. So here I will say that my RAM part is the part that I'll use to group these fonts into different groups. So fonts that have a RAM of 3000 to 4000 mostly should be in group 2. So 1000 to 3000 can be in group 3. Then 1000, so around 500 to 3000 can be in group 1, and 0 to 2000 should be in group 0. So something like that. And basically that's how k-means work. So it's the main purpose of us using this model is to group data into groups that have similar characteristics where we don't know the labels that we need to use for the data. So that should be all from my side concerning the k-means, hierarchical clustering, and clustering as a whole. So you can create a hierarchical clustering model on your side and do the visualization also and compare what you will get for k-means and hierarchical clustering. Yeah, so that's all from me for today. Any questions? Okay, so the silence means we have no questions. Yes, Samuel.
I think, yeah, using the data set that we can be able at least to relate with, I think it has come out clear.
Yeah.
Like the way you're saying, based on the RAM, we can also see and we can also. So I think for me, at least today, I've understood exactly the purpose of K means, and although
Clustering
I've
as a
not
whole.
done the high, sorry.
Like you've understood the clustering part as a whole, like
Yes,
how clustering works. Yeah.
yes, yes, and of course I'll go and practice the hierarchy one
Yeah.
and see the output. And also, I've also learned a lot on the EDA. I think part of the EDA course is the same thing, it's just that, especially when you're comparing, I have
Yeah.
never, I mean, done it the way you've done when you're trying to to understand the data. I think
Okay.
that's part of also, I don't know whether we've ever learned, but I've learned quite a lot today.
It's okay. So I
Yes,
think maybe we can be focusing more on EDA also, because machine learning is just this part. So
yes, yes.
yeah, what I think we will do is we will be so what we will be doing is we will be doing more of EDA so that you can see how I go through my data, how I check for trends, how I interpret my data. So for the upcoming classes, we will be focusing more on EDA because machine learning is just a small part and EDA is the most important part. So I'll be teaching you guys how you can explain what you are seeing from your data. So I hope others have learned something too from today's session. Okay. Anyone else with a question or a comment? Yes, Ephraim.
Hello.
Hello.
Yeah, I think we should do more of that to get that part of machine learning
It's
going
okay.
in the project. Yeah.
Okay, okay. That's fine then.
Yeah.
We will focus more on that. So let me upload today's